Hello my scholars, you are welcome to my school YouTube channel and my name is Frank. In today's video we shall be tackling JAMB CBT physics past question for the year 2024. So please do not go anywhere, relax and I'll be right back. You are welcome back to my school YouTube channel. In today's video, we shall be answering question 1 to 25. So let's kick off with question 1. The stress experienced by a wire of diameter y over pi meter loaded by a weight y square Newton is... So let's move over to the board to provide answer to this question. Now remember that stress is given as force all over area. Okay, so in this case the wire will be considered to be cylindrical, right? So and the area will be equals to pi r squared. So in this place we have to get the value of radius from the diameter by simply multiplying this value that is given to us by 1 over 2, okay, which is the same thing as dividing this by 2. Okay, so if we multiply this by 1 over 2, we'll be having y over 2 pi meter, right? So it's just for us to substitute. So remember that weight is the force acting on the body due to gravity, right? So weight and force are literally the same. So here we have our y square over, so here will be pi times y over 2 pi in bracket square. Remember, y over 2 pi represents our radius, right? And our radius from our formula here is squared, okay? So that will be having y raised to power 2 all over pi times y square all over 4 pi square, okay? So this 4 pi square will move up so that we'll be having y square times 4 pi square over pi times y square. So y square will cancel out y square, pi will cancel out 1 pi from here, so that will be having 4 pi, okay? So the value of the stress is equals to 4 pi Newton per meter square, okay? So let's return back to the screen to pick the correct answer to this question, and that is option C, 4 pi Newton per meter square. Question 2. Under which conditions is work done? Now remember, work is said to be done whenever a force moves an object a distance in the direction of the applied force. Okay, so let's go through the options. A man supports a heavy load on his head with his hand. Then option B, a woman holds a pot of water. So option A and option B are almost the same thing because in both of them no work is done. Okay, the man only supports a heavy load on his head using his hand, while the woman holds a pot of water. So let's go to option C. Option C, a boy climbs onto a table. Now in option C, work is actually done because the boy did work of lifting his own weight from the floor onto the table, right? And he actually did that work against the force of gravity, okay? While option D, a man pushes against a stationary petrol tank. So the man pushing against stationary petrol tank is not doing any work. In fact, it's actually wasting his time. Why? Because the petrol tank did not move from that particular, the place it was initially, to another position, okay? So based on everything that I've said so far, option C is the correct answer to this question. A boy climbs onto a table. Question 3. The mechanical advantage of the machine shown above is, okay, so the machine shown above is a wedge, right? And we know that mechanical advantage is equals to load all over effort. So in the case of a wedge, the mechanical advantage is load distance all over effort distance, okay? So the height, okay, which is this vertical height, represents the load distance, while the weight represents the effort distance. Okay, so since mechanical advantage is equals to load over effort, so in this case we'll be having 15 divided by 0.5, and this will be equals to 30. Okay, remember that mechanical advantage is a ratio, so it does not have any units. Okay, so that makes option C the correct answer to this question. Question 4. Rainbow is formed when sunlight undergoes A, we have reflection. Okay, so reflection involves the bouncing off of light, okay, on a surface, right? So reflection itself is not the complete process for the formation of a rainbow. Then option B, we have refraction. So refraction is the bending of light when it passes through different medium, right? So refraction, though it is one of the process or one of the means by which rainbow occurs, it is not the complete process. Then option C, we have dispersion. So dispersion is actually the primary process, okay, responsible for the formation of rainbow. So this formation of rainbow occurs when sunlight passes through water droplets suspended in the atmosphere, causing the light to separate into its constituent color. While option D will have diffraction, which is the bending of light wave around obstacle. Okay, so the answer to this question is option C, dispersion. Question 5. Find the value of a capacitor with voltage 5 volts and 30 coulombs. Okay, so we know that capacitance is equals to C. Capacitance C is equals to quantity of charge all over voltage, right? So in the case of this question, we are given quantity of charge to be equals to 30 coulomb and voltage to be equals to 5. So we just substitute here, so that we'll be having 30 divided by 5, and that will be equals to 6 farad. Okay, so that makes option B the correct answer to this question. Question 6. When a bus is accelerating, it must be A, changing its speed, B, changing its velocity, C, changing its position, D, changing its direction. So when a bus is accelerating, it actually means that the bus can accelerate by changing its speed or direction or both, right? But remember that we define acceleration as the rate of change of velocity with time. So when a bus is accelerating, the bus must be changing its velocity. So that makes option B the correct answer to this question. Question 7. The friction due to air mass can be reduced by A, we have streaming. So streaming simply refers to the streamlined shape of an object, right? So the streamlined shape of an object helps to minimize air resistance, in this case drag, okay? Helps to minimize air resistance, in this case drag of the object, of an object moving in air, okay? So B, we have lubricating. So lubricating helps to reduce friction between the parts of a moving object, right? Then C, we have propeller. So propeller is just like a device that propels an object into motion. While D, we have polishing. So polishing actually does not reduce friction, it actually increases friction. Okay, so the answer to this question is streaming. So streaming helps to reduce air drag, okay, or resist air resistance of objects that are moving in air. Option A, sorry, is the correct answer to this question. Question 8. Which of the following operates based on magnetic effect of electric current? A, we have electric heater. So the electric heater operates based on the heating effect of electric current. While B, photocell. So photocell operates based on the photoelectric effect. While C, dynamo. Dynamo is a device that generates electricity, okay, which operates based on the magnetic effect of electric current. While we have option D, cathode, cold cathode. So cold cathode is a type of lamp, okay, that operates based on the principle of gas discharge. So the answer to this question is dynamo. So dynamo is a device that operates based on the magnetic effect of electric current. Question 9. When a charged ebonite rod is brought near a charged glass rod, there will be A, attraction, B, repulsion, C, spark, D, no force experience. Okay, so an ebonite rod is charged by rubbing it with a force, so the ebonite rod will acquire negative charge, while a glass rod is charged by rubbing it with a stick, and the glass rod will become positively charged. And remember that opposite charges attract. Okay, so when a charged ebonite rod is brought near a charged glass rod, there will be force of attraction between the rod. So that makes option A the correct answer to this question. Do you know you can take practice question with our JAMB simulated CBT past question? All you need to do is to click on the link in the description below and that will take you to my school website. There you have to download my school mobile app for your Android devices and my school software for your laptops and computers. Please go ahead and start practicing. Moving on to question 10. Pilots uses analog barometer to know the height above sea level because A, very accurate. Why the analog barometer can give very accurate measurements of height above sea level? There are other types of barometer with higher precision. Why B will have small and convenient. So the analog barometer is compact and portable, making it suitable for use in aircraft where size and weight are consideration. While option C, we have heavy and huge. So the analog barometer is compact, okay, and portable. While option D, we have costly. So the analog barometer is quite cheap compared to other types of barometer. So the correct answer to this question is option B, small and convenient. So because of the small size and convenient use of the analog barometer, it is suitable for use in aircraft where size and weight are consideration. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 11. A light ray passing from air into water at an angle of 30 degrees from the normal in air would A, make an angle greater than 30 degrees in water surface, B, be completely absorbed by the water surface, C, be completely reflected by the water surface, D, make an angle less than 30 degrees from the normal in the water surface. So when a light ray passes from air into water, the light ray normally refracts towards the normal. So according to Snell's law, the angle of refraction will be less than the angle of incidence when the light ray is moving from a less dense medium to a denser medium. Okay, so that makes option D the correct answer to this question. Make an angle less than 30 degrees from the normal in the water, and the reason for that is because air is a less dense medium when compared to water, which is a denser medium. So option D is the correct answer to this question. Question 12. A solid cube of aluminium is 1.5 centimeter on each edge. The density of aluminium is 2,700 kilogram per meter. Find the mass of the cube. So let's move over to the board to provide answer to this question. So we are told that the size of the side of the aluminium cube is 1.5 centimeter, and we are given the density of aluminium. But remember that density is equals to mass all over volume. Okay, density is given as mass all over volume, right? So in this question, we are actually calculating for mass. Okay, so just make mass the subject of formula by cross multiplying. So if we cross multiply, the mass of the aluminium equals to the density times the volume, right? So since we are given this and we are looking for volume, in that case it's going to be s raised to power 3, right? The volume of a cube is s raised to power 3, which is the side multiply itself thrice, right? So in this case, we're having 1.5 times 1.5 times 1.5, and this will be equals to 3.375 centimeter cube, right? So this is the value of the volume of the solid cube, right? Now this density, we have to convert it to gram per centimeter, right? You have to convert to gram per centimeter by dividing by 1000. So if we divide this by 1000, we're having 2.7 grams per centimeter, right? So since we are looking for mass, so we just multiply our new density with the volume. So in this case, we're having 2.7 times 3.375, okay? And this will be equals to 9.1125, right? So this will be equivalent to 9.1 grams since we are looking for the mass of the aluminium. So let's move over to the screen to pick the correct answer to this question. Okay, so the mass of the cube, okay, the aluminium cube is equals to 9.1 grams. So that makes option B the correct answer to this question. Question 13. The value of arrow required to make the galvanometer measure voltage up to 40 volts in the diagram above is. So let's move over to the board to provide answer to this question. So these values are extracted from the diagram that is given us above. So where arrow here refers to internal resistance, while I here refers to galvanometer current, right? So we have to use this formula. V is equals to I bracket open arrow plus small letter r. Okay, so this is the resistance that we are actually asked to calculate for. So we just make it the subject of the formula. So we'll divide both sides by I first, right? So that we'll be having V over I is equals to arrow plus, that is capital letter arrow plus small letter arrow. So since we are looking for capital letter arrow, then we'll make it the subject of formula by moving the small arrow to this other side. So that big arrow will be equals to V all over I, then minus the small arrow. Okay, so we have to convert this 20 milliampere to ampere by simply dividing it by 1000, right? So if we divide it by 1000, we're having 0.02 ampere. So the next is just for us to substitute our value. Now remember that the voltage that we are to measure is 40 volts. Okay, so here will be equals to 40. So we put our 40 here all over the current of the galvanometer, which is 0.02, then minus the resistance, the internal resistance, which is 10. Okay, so remember that this is the same as 40 divided by 2 over 100, right? This is just 1, 2. So this is 2 over 100. Of course, this is going to move up. So that we'll be having 40 times 100 divided by 2. Now remember, I've not forgotten our minus 10, which is the internal resistance. So 2 here will be 1, 2 here will be 2. So if we multiply out, we'll be having 2000, right? So 2000 minus 10, that will be equals to 1990 ohms. Okay, so let's return back to the screen to pick the correct answer to this question. Okay, and that is option B, 1990 ohms. Question 14. 5 times 10 raised to power minus 3 kilogram of liquid at its boiling point is evaporated in 20 seconds by the heat generated by a resistor of 2 ohms when a current of 100 ampere is used. The specific latent heat of vaporization of the liquid is. So let's move over to the board to provide answer to this question. The heat actually required to evaporate the water at its boiling point is given as I square ROT. Okay, and this heat will be equal to ml, where m here stands for the mass of the liquid, while L here stands for the specific latent heat of the liquid. Okay, so we are given the mass of the liquid to be equals to 5 times 10 raised to power minus 3 kg, and we are looking for latent heat. But remember, here we are giving current to be equals to 10 amperes. So here we write 10 square, then times the resistor is given to us to be equals to 2 ohms, then times time, which is 20, right? So this will be equals to 100 times 2 times 20, and this will be equals to 5 times 10 raised to power minus 3 times L. Right, so if we multiply everything together here, we'll be having 4000. Okay, and this is equals to 5 times 10 raised to power minus 3 times L. Now, since we are looking for the value of L, which is the specific latent heat of vaporization of the liquid, we divide both sides by 5 times 10 raised to power minus 3. Okay, so that our L now becomes 4000 divided by 5 times 10 raised to power minus 3. But remember that this your 5 times 10 raised to power minus 3 is still the same thing as say 4000 divided by 5 all over 1000. Okay, basically they are the same. So this is going to move up. So that will be having 4000 times 1000 divided by 5. Okay, so 5 here is 1, 5 into 40 is 80. Right, so if we combine this together, we'll be having 800,000. So the specific latent heat is equal to 800,000. Okay, so the 800,000 we can put it in standard form. So that we'll be having 8.0 times 10 raised to power times 10 raised to power 5. Okay, so let's return back to the screen to pick the correct answer to this question. Okay, and that would be option B, 8.0 times 10 raised to power 5 joule per kilogram. Question 15. If the SVP of water vapor was 13.5 millimeter of mercury at 33 degrees Celsius and 7.3 millimeter of mercury at 7 degrees Celsius, find the percentage relative of the air on a day when average air temperature was 33 degrees Celsius and dew point was 7 degrees Celsius. So this question, basically they are asking us to calculate relative humidity. Okay, so let's move over to the board to provide answer to this question. Now, since we are looking for relative humidity, which is in this case will be equals to SVP, which is saturated vapor pressure at dew point, okay, all over saturated vapor pressure at air temperature times 100, okay, over 1. So we just substitute our values to get our answer. In this case, we have 7.3 divided by 13.5 times 100, okay, and this will be approximately equal to 54%. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option C, 54%. Question 16. Electrolysis can be investigated using A, voltmeter, B, ammeter, C, galvanometer, and D, voltammeter. So electrolysis, which is the chemical decomposition of a compound by passing current through its molten or aqueous state. Okay, so let's see A, option A, we have voltmeter. So voltmeter is used to measure voltage in a circuit, while B, we have ammeter. So ammeter is used to measure current flowing in a circuit, while C, we have galvanometer. So galvanometer is a sensitive device used to detect and measure small current, while option D, we have voltammeter. So voltammeter is actually the instrument that can be used to investigate electrolysis. Okay, so the voltammeter consists of two electrodes that are dipped in a liquid contained in a container, and another word for your voltammeter is also known as electrolytic cell. Okay, so that makes option D the correct answer to this question. Question 17. A wheelbarrow inclined at 60 degrees to the horizontal is pushed with a force of 150 Newton. What is the horizontal component of the applied force? Okay, so to solve this, since the wheelbarrow is inclined to the horizontal, right? So to get the horizontal component of the force, we use Fx is equals to F cos theta. Okay, but if, for example, if you are asked for the vertical component, then in that case you use Fy is equals to F sine theta, right? But in this case we are asked what is the horizontal component of the applied force. Okay, so we are going to be using F cos theta. So F is given to us to be equals to 150, then times cos theta. So cos theta here is 60 degrees, right? But remember that 60 degrees is one of those special angles, right? And cos 60 is the same thing as 0.5, right? So here we have 0.5. So 150 times 0.5, which is the same thing as, say, 150 times 1 over 2, that will be equals to 75 Newton. Okay, so this will give us 75 Newton, and this makes option B the correct answer to this question. Question 18. In a solar panel, solar beam is concentrated by using A, concave mirror, B, convex mirror, C, plane mirror, D, triangular mirror. So the answer to this question is option A, concave mirror. So concave mirror is used to focus light rays onto a single point, making it suitable for concentrating solar beam onto a solar panel. So option B, convex mirror. So convex mirror actually diverges light rays, right? While for C, plane mirror only reflect light rays without focusing them. While for option D, triangular mirror is the same thing as glass prism. Okay, so the answer to this question is option A. Why? Because the concave mirror is used to focus light rays onto a single point, making it suitable for concentrating solar beams onto solar panels. Question 19. A rectifier is a device that changes A, DC to DC, B, DC to AC, C, AC to AC, and D, AC to DC. So a rectifier is a device that enables current to flow in one direction while blocking it in the opposite direction, transforming it from AC voltage to a form of DC voltage suitable for different applications. So what I'm saying in essence is that a rectifier is a device that actually changes alternating current to direct current. Okay, so that makes option D the correct answer to this question, a device that changes alternating current to DC current. If you have any question to ask, please feel free to ask your question by clicking on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our team of solution providers will provide answer to all your questions within a short period of time. Moving on to question 20. The dimension of Young's modulus E is given by, so let's move over to the board to provide answer to this question. So Young's modulus E is given as stress all over strain, okay? But remember that your strain is dimensionless, so that implies that the dimension of your modulus is the same thing as the dimension of stress. So let's derive the dimension of stress, okay? Remember that stress is force all over area, right? And force itself is equal to mass times acceleration, right? So this is our area. So each of these variables now, so let's get their dimension. So the dimension of mass is Tm, and the dimension of acceleration is actually length times t raised to power minus 2, while that of area is length squared. Okay, so if we apply the law of indices here, we'll be having the dimension of stress to be equals to m, then L raised to power minus 1, then T raised to power minus 2. So this is the dimension of stress, and which is equal to the dimension of Young's modulus. So in essence, this is the dimension of Young's modulus, m times L raised to power minus 1 times T raised to power minus 2. So let's return back to the screen to pick the correct answer to this question, okay? And that is option C, m L raised to power minus 1, T raised to power minus 2. Do you have better solution or steps in solving any of these questions? If yes, please, you can go to the comment section below to comment the question number and the solution you wish to share. Question 21. The moon's acceleration due to gravity is 1/6 of the Earth's value. The weight of a bowling ball on the moon would be A, 6 times its weight on the Earth, B, 1/6 of its weight on the Earth, C, 36 times its weight on the Earth, and D, equal to its weight on the Earth. So let's move over to the board to provide answer to this question. So these are what is given to us. We are told that we know that acceleration due to gravity on the Earth is approximately equals to 10 meters per second square, okay? And according to this question, we are told that acceleration due to gravity on the moon is equals to 1/6 of that on the Earth, okay? So let's say m here, okay, mb is the mass of the bowling ball, right? And want to calculate the weight of the bowling ball on Earth. So weight on Earth will be equals to mass of the bowling ball, right, times 10. So this will be equals to 10 mb, right? Now we can as well calculate the weight on the moon, okay? So the weight of the bowling ball on the moon will be equals to mb, right? Remember that mass is constant, right? So that will be equals to mb times 10 all over 6. Remember that we are told that the acceleration due to gravity on the moon is 1/10 of that on the Earth, okay? And that of the Earth is approximately equals to 10 meters per second square, which is what we use here. So if you look at this, you discover that the weight on the moon will be equals to mb, okay, then 10 divided by 6, right? So if you check very well, you discover that the weight on the Earth is greater than the weight in the moon. So in that case, we can say that the weight of the bowling ball on the moon is 1/6 of its weight on the Earth, okay? So let's move over to the screen to pick the correct answer to this question, and that is option B, 1/6 of its weight on the earth. Question 22. If a sheet of an insulating material is inserted between the plates of an air capacitor, the capacitance will A, become 0, B, decrease, C, increase, and D, remain unchanged. So the answer to this question is option C, increase. Now going by this relationship, C is equals to epsilon naught A all over D. Okay, so if an insulating material is inserted between the plates of an air capacitor, what happens is that the permittivity of the dielectric material is usually greater than that of air capacitor, okay, than that of air. So inserting it into the inserting it in between the plates of the air capacitor will actually increase the capacitance of the capacitor, okay, going by this formula, and that makes option C the correct answer to this question. Question 23. 288 kilojoule is conducted across two opposite faces of a 3 centimeter cube of temperature gradient 90 degrees per meter in 7,200 seconds. Calculate the thermal conductivity. So let's move over to the board to provide answer to this question. So we have formulas for calculating thermal conductivity, which is given as K is equals to Q dot D all over area times change in temperature times time. Okay, so where Q stands for the quantity of heat, where D stands for the thickness, okay, of the material, while A stands for the area of the material, where D delta T stands for change in temperature, and small letter T stands for time. Okay, so let's change this to kilogram to joule. Okay, so this will be equals to 288,000. Right? Remember that the thickness of the material is also equal to the size of the face, okay, of the shape of the object, which is, in this case is a cube, right? So the area will be equals to S squared. That will be 3 times 3. That will be equals to 9 meter cube. Okay? So here we need to calculate for change in temperature. So if you look at this question very well, we are given temperature gradient. And remember that temperature gradient is also defined as the temperature difference, okay, per unit length of heat transfer path. Okay, so in this case, our change in temperature will now be equals to temperature gradient, okay, temperature gradient times the thickness of the material. Okay, so in this case, we are having 90 times. Of course, remember that 90 degrees per meter is still the same thing as say 90 Kelvin per meter. Okay, so if we multiply 90 by 3, we'll be having 270 Kelvin. Okay, in this case, we're having 270 Kelvin because of change in temperature, right? So we just substitute our values so that our K, which is the thermal conductivity, becomes 288,000 times the thickness, which is 3, then divided by area, which is 9, times the change in temperature, which is 270, then times time, which is 7,200, right? So 0 we cancel 0, then this 0 we take out this 0, 3 here is 1, 3 here is another 3, right? So if you multiply the numerator and divide it by multiplying the denominators, to the result of multiplying the denominators, we'll be having approximately 4.93 times 10 raised to power minus 2, okay, minus 2 watts per meter per Kelvin. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option A, 4.9 times 10 raised to power minus 2 watts per meter per Kelvin. Question 24. A sonometer's fundamental note is 50 Hz. What is the new frequency when the tension is 4 times the original? So let's move over to the board to provide answer to this question. So we know that for a sonometer, frequency is directly proportional to square root of the tension. Okay, so in this question, the original frequency is given to us to be equals to 50 Hz, while the tension, which is T1, is equals to T1, but we are told that the new tension is equals to 4 times the original one. Okay, so in this case, we'll be having 4 times T1, right? So if we are to make this an equation, we'll be having F is equals to K root T, right? So we make K the subject of formula, so that we'll be having F all over root T is equals to K. Since this is a constant, so we can actually have F1 all over root T1 is equals to F2 all over root T2. Okay, so let's substitute these values into this equation to get the value of F2. So our F1 is 50, while our T1 still remains T1, while F2, the frequency we are looking for, while our T2 is equals to root 4T1. Okay, so we cross multiply and make F2 the subject of formula, so that F2 is equals to 50 times root 4T1 divided by root T1. Okay, so this becomes 50 times, of course, root 4 is the same thing as 2, right, times root T1. Okay, so if we have root 4T1, right, it's still the same thing as, say, root 4 times root T1. Okay, so that's exactly what I did here according to sort, right? So divided by root T1. So root T1, we cancel out root 2, and so that the new frequency becomes 50 times 2, and that is equals to 100 Hertz. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option B, 100 Hertz. Question 25. Which of the following is not a part of model rocket? A, the body tube, B, the nose cone, C, the fins, D, not recovery devices. Okay, so option A, the body tube is part of a modern rocket, B, the nose cone is also part of a modern rocket, and C, the fin is also part of the modern rocket. But in the modern rocket, there's nothing like not recovery devices, although we have recovery devices such as parachute and streamers. Okay, so option D is the one that is not part of a modern rocket, which is not recovery devices. I believe you enjoyed this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos.